already know how to carry out titrations, but if you've forgotten, watch part 1 again and refresh your memory. In part 2, we will see how to do titration calculations. We will look at 2 different examples together and then one for you to try out yourself. These calculations enable us to work out the actual concentration of an unknown solution. So let's look at an example. We have carried out a titration. We started with 25 cubic centimeters of an unknown solution in the conical flask. We then added 20 cubic centimeters of the known solution of concentration 0.5 mol per cubic decimeter to complete the reaction. What is the concentration of the unknown solution? First, we need to convert volumes to cubic decimeters. We do this by dividing by 1000. So 25 cubic centimeters divided by 1000 equals 0.025 cubic decimeters. And 20 cubic centimeters divided by 1000 equals 0.02 cubic decimeters. Now you need to work out the number of moles for the known solution, because we already know the concentration and volume for this. The number of moles equals concentration multiplied by volume. So in this case, for the known solution, the number of moles equals 0.5 multiplied by 0.02, which equals 0.01 mole. Using this, we can now calculate the unknown concentration. The concentration of the unknown solution equals its moles divided by volume, which equals 0.01 divided by 0.025, which equals 0.04 moles per cubic decimeter. So the unknown solution was at a concentration of 0.04 mole per cubic decimeter. It is much easier to take the time to understand what is happening, but if you prefer to just learn an equation, this is all you will need to know for titration calculations. Using the values we've just determined, we can make use of the following formula. The concentration of the unknown solution equals the concentration of the known solution multiplied by the volume of the known solution divided by the volume of the unknown solution. So, the unknown concentration equals 0.5 multiplied by 20 over 25, which equals 0.4. But you may not pick up all the marks in the test or an exam using this formula because it doesn't show your understanding. Sometimes you need to work out the proportions involved in the reaction by looking at the equation for the reaction. So if we had this question, the balanced equation would look like this. So 2 moles of sodium hydroxide reacts with 1 mole of sulfuric acid. We are now ready to do the calculations. Convert the volumes to cubic decimeters. 20 cubic centimeters divided by 1000 equals 0.02 cubic decimeters. 40 cubic centimeters divided by 1000 equals 0.04 cubic decimeters. Now calculate the moles for the known solution, sodium hydroxide. The number of moles for sodium hydroxide equals 0.5 multiplied by 0.02, which equals 0.01 mole. Now calculate the concentration of the unknown solution. The concentration of the unknown solution, sulfuric acid, equals 0.01 divided by 0.04, which equals 0.25 mole per cubic decimeter. But from the equation, we know that 2 moles of sodium hydroxide reacts with 1 mole of sulfuric acid. So 0.25 is for 2 moles because we have so far assumed a 1-to-1 ratio. So we need to divide this by 2 to get 1 mole of sulfuric acid. So 0.25 divided by 2 is 0.125. Now here's a question you can try out on your own. Pause the video, work out the answer, and click play when you're ready to check. Did you get 0.3 mole per cubic decimeter? Here's how you work it out. So using these titration calculations, we can work out the exact concentration of an unknown solution. We have to carry out the titration first, so that we know the exact volume and concentration of a known solution, and then we also need to know the volume of the unknown solution. Armed with this knowledge, we can then work out the exact concentration of that unknown solution.